So the last kinematic graph we look at is the acceleration versus time graph, and that's where the y value is the acceleration, and then the slope doesn't have any physical meaning because the slope, because if I have an axis here with the acceleration versus time, and we look at the slope being the change in the y variable over the change in the x variable, what we find is it doesn't mean anything. This is this is known as the jerk, but it's not covered in AP Physics 1. So you can know that as a fact just for fun, but we don't cover it. No physical meaning. We don't handle the rate of change of the acceleration, okay? Because remember, in AP Physics 1, we mostly deal with constant acceleration. Now, the area is a little more interesting because you remember if our velocity is, acceleration is the change in velocity over the amount of time, right? This is our average acceleration formula. That's the definition we said of acceleration. So if you move that up there, what you get is this is the area, it's the y variable times the change in the x variable, and that's going to give us our change in velocity. So the area is going to give us the change in the velocity, and this is a little bit more tricky because we talked about the area under the velocity time graph being the displacement last time, but for the area under the graph here being the change in velocity, you got to think about the initial velocity and the final velocity and think about that change. So let's go through an example here. So we have a graph of acceleration versus time where the y value is the acceleration, the slope is the change in the y variable over the change in the x variable, and that is meaningless. And the area is the y variable times the change in the x variable, and that is the change in velocity there. Okay, so we're saying that the bicycle has a velocity at 40 meters per second at t equals 0. So at t is equal to 0, we know the velocity is 40 meters per second. And now we want to know the speed at 10 meters per second. So we look at the area here. So this is a key part. We're going to look at this area between the axis and the graph here, and we want to go up to 10. So therefore, we know the area. So let's look at the area. Let's split it up into two triangles and a rectangle. So if we do this area, this is going to be 1/2. The base is 4, and the height is -4. Right, like there, because this width is 4 and this height is -4, so that's going to be -8. And then we have this it looks like a square, not really a square because the axes are different. So this is going to be the width from 4 to 8 is 4, and then the height is -4, so that's -16. And then the area here is going to be the width from 8 to 10. That's going to be 1. So the area of a triangle, the width is 2, and the height is -4. And so that's going to be -4. And so then we look at this and we say oh, that means the area is the change in velocity. That's going to be -8 minus 16 minus 4, and that's going to be -28. Now, it doesn't mean that she's going -28. That's the change. And the change is the final minus the initial. All right? That's the difference. And we know we started at 40. So this is v minus 40 is equal to -28. We're going to add the 40, and you get -28 plus 40, right, is going to give you 12 meters per second is the velocity there. Okay. Which direction is a child moving at 14 seconds? So now we need to know the velocity here. So we're going to take a look at this area now here, and this area is going to be 1/2. That's going to give us a change in the velocity. Because remember that for direction of motion, we want to look at the sign of the velocity, right? So 1/2, the area of this is 1/2. The width is from 10 to 14. That width is 4. That height is +4. And so that's going to be 8. So that means the change is 8 here from 10 to 14. So there's two ways to think about it. You can think about the change, okay, so that the change in velocity is 8, and that equals the velocity at 14 minus the velocity at 10. Okay, so because it's the change from there to there. Right? And so this is the velocity at times 4. This is not multiplying, this is a function notation. Velocity at 10 is 12. So you get 8 here. So then you can add that, and you get 20 is equal to the velocity at 14. So that's 20 meters per second. That's one way to look at it. Okay, is that he gained 8 meters per second. That's the change in velocity. So let's say, well, at this point he's going 12 meters per second. His change was 8. He gained 8 meters per second. And so now he's at 20 meters per second. Okay, you can do it from the initial. You could say, well, what the total area is. You could also think about it as, oh, the area from here to here is negative. We knew this is -28 plus 8. So it's -28 plus 8. That's -20. And you could say but if you do the area from time 0, then you have to say oh, he started at 40 meters per second, and his change was minus 20, and so he ends up at 20 meters per second. So either way you want to do it, whether you want to do it from this time or start just from here to here, doesn't really matter because the area is just the change. You're just doing the area between the 2 points, and it is just the change during that time interval. When is the acceleration constant? Well, the y value is the acceleration. So this is to say is when is the y value constant, right? And the y value is only constant, if you look at this graph here, only here and here. Being 0 is still constant, right? So y value is constant. That occurs between 4 and 8. I'm going to clear this part out a little bit so you can see the axes. Between 4 and 8 is where the velocity is not changing. And then also between 14 and 16. Okay, like that. At what times is the velocity constant? Okay, so the velocity constant's pretty tricky, right? Because we only know the area is the change in velocity. So the velocity is constant. There's two ways you can think about this. You can think of it as like, oh, the default way is the acceleration is 0. Or if you want to look at it from an area point of view, you could say the change in velocity is 0. Because if the change is 0, like there's no change in the velocity, then the velocity is going to be constant, right? So when is the acceleration 0 or the change in velocity 0 is right here. The y value being 0. Or you can think of it as the area under the graph. The area of here is 0 because it's just, there's no area, right? There's no gap between there. And so that becomes between 14 and 16 seconds. At what times does the bicycle change directions? Okay, so changing directions is a little bit tricky. You have to think about when it started off positive. So remember, direction is the sign of the velocity. Right now, the velocity is positive and positive. So does the velocity ever get negative? Well, we would have to have, see, at this point, we know we calculated before, we're going at 20 meters per second. And we're going to have some change here, right? But that area, if you think about that change, that's going to be 1/2. The base's width is 2. From 16 to 18 is 2. And the height is -4. So that's going to be -4 meters per second. So here we're going to go 16 meters per second. So the whole time, the velocity is actually positive. So it never changes directions because it stays positive. So we say never because the velocity is greater than 0 the entire time. If the velocity switched from positive to negative, then it would change direction. Remember, direction being the sign of velocity there. Okay? Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.